Welcome back to Creative Alternatives. Today we are exploring alternatives to animal agriculture. You may not realize it yet, but the future of food is being built right now quietly, rapidly, and with the power to reshape the planet in a single generation. Imagine a world where food no longer demands vast landscapes stripped for grazing, where no forests are burned to feed cattle, where oceans recover, and where the dinner on your plate comes without the shadow of environmental destruction. This isn't science fiction. It's happening today, and it's unfolding faster than most people think. As the limitations of animal agriculture become increasingly impossible to ignore, a new ecosystem of alternatives, smarter, cleaner, and profoundly more efficient, is emerging to redefine how humanity feeds itself. Animal agriculture for centuries has been the backbone of global diets, but it comes with a cost that is no longer sustainable. Livestock production consumes enormous areas of land, accounting for around 77% of agricultural land, even though it provides only a fraction of the world's calories and protein. Add to that the methane emissions, the water footprint, and the accelerating deforestation in some of the planet's most fragile regions, and it becomes painfully clear. Continuing on the current path is a losing game. Global demand for meat and dairy continues to rise, but the planet's ecological capacity to support this demand is shrinking. Something has to change. Something already is changing. The first major shift comes in the form of plant-based alternatives foods designed to mimic the taste, texture, and experience of meat, dairy, and eggs without requiring a single animal. These products aren't just for vegans or vegetarians anymore. In fact, the majority of people buying plant-based burgers, milk, or nuggets today are omnivores looking for healthier, lighter, or more environmentally responsible choices. That's a massive cultural shift, and it's important because large-scale change doesn't happen through purity, it happens through accessibility. What's driving this expansion is a combination of technological innovation and a growing awareness of the environmental impact of traditional livestock production. Companies are now capable of using advanced food science techniques to recreate the sensory experience of animal-based foods. Hemoglobin-like molecules made from plants give burgers their juiciness and bleed. Precision-controlled high-pressure extrusion helps replicate fibrous textures that were once considered impossible to achieve without muscle tissue. Meanwhile, plant-based milks have evolved from thin, watery substitutes into thick, creamy options capable of frothing for cappuccinos or stretching in mozzarella-style melts. One of the most powerful aspects of plant-based alternatives is their efficiency. Producing plant-based meat uses significantly less water, emits fewer greenhouse gases, and requires dramatically less land. This is because instead of feeding calories to an animal over months or years, those calories go directly to the consumer. In essence, plant-based foods cut out the middleman. As a result, the resource savings are enormous. A plant-based burger requires up to 90% less water and land compared to a beef burger, and it avoids the methane emissions entirely. These differences matter on a global scale, where every degree of warming, every hectare of forest preserved, and every drop of fresh water protected represents critical progress. Health is another major force encouraging people to reconsider their relationship with animal-based foods. While not all plant-based products are created equal, many are lower in saturated fat and cholesterol. Some contain higher fiber levels and fewer inflammatory components. Consumers are becoming more label-conscious, paying closer attention to what goes into their food, and many appreciate the transparency of ingredient lists based on beans, grains, nuts, and oils rather than hormones or antibiotics. As more research highlights the link between high meat consumption and chronic diseases, more families are choosing to diversify their meals. But what truly sets the modern plant-based food movement apart from earlier waves of vegetarianism is flavor. In the past, plant-based options were often relegated to bland, rubbery substitutes. Today, food scientists, chefs, and agricultural experts collaborate to design products with culinary appeal in mind. Restaurants from casual chains to Michelin-starred kitchens incorporate plant-based dishes not as afterthoughts but as centerpieces worthy of attention. Fast food giants include plant-based options not out of obligation, but because the demand is real, consistent, and growing. Expanding global accessibility is also key to the rise of plant-based alternatives. Across Asia, Africa, and South America, local innovators are developing culturally relevant products that reflect regional palates and ingredients. In India, for example, plant-based versions of traditional dishes blend seamlessly into long-standing vegetarian culinary traditions. In Latin America, startups use native crops like lupin beans or chickpeas to create high-protein alternatives. These regionally tailored solutions not only diversify global food options, but also support local agricultural economies. Despite the fast-growing industry, plant-based alternatives face certain challenges. Some consumers express concerns about processing levels, ingredient familiarity, or costs that, while declining, can still be higher than conventional meat in some regions. Critics argue that replacing one system of industrial food production with another may not solve every problem. These critiques are valid and necessary because they push companies toward greater transparency, cleaner formulations, and better pricing structures. Every wave of innovation starts with imperfect prototypes before refining into mature systems. Plant-based food is no exception, but its trajectory has consistently pointed toward improvement, and this raises a crucial point. Plant-based alternatives are not about forcing everyone to give up meat forever. They're about expanding choices. They're about building a food system resilient enough to sustain 10 billion people without collapsing under the weight of its own environmental burden. By adding new tools to our food toolbox, we reduce dependency on outdated methods that no longer serve the modern world. The potential is enormous. Imagine global menus where plant-based meals are not alternatives, but normal, everyday options. Imagine farms shifting from monocrop production meant solely to feed livestock toward regenerative agriculture practices that enrich soil, restore ecosystems, and nourish communities directly. Imagine young entrepreneurs in every region of the world developing ingredients that honor their heritage while contributing to global sustainability. We're witnessing the early stages of a transformation whose impact will be felt for generations. Plant-based alternatives are more than a trend, they're a foundational component of a sustainable, ethical, and abundant future of food. And while they're only one piece of the puzzle, they're a powerful one. They represent a turning point where society begins to decouple delight from destruction, nourishment from ecological cost, and tradition from inevitability. If this is what plant-based innovation looks like today, the next frontier promises even more dramatic breakthroughs. Because the shift away from animal agriculture isn't just happening in fields and kitchens, it's happening in laboratories and bioreactors, where the next evolution of food production is already underway. It's easy to imagine the food of the future as something distant, abstract, or disconnected from daily life, but that future is already being plated in restaurants, tested in facilities, and scaled in enormous stainless steel tanks that look more like the infrastructure of clean energy than agriculture. In the next decade, one of the most profound shifts in human food production won't come from fields or pastures at all. It will come from bioreactors-controlled environments where cells grow into real meat without requiring a single animal to be raised or slaughtered. And this revolution in cultivated meat has the potential to outpace even the most ambitious plant-based innovations. Cultivated meat, also called cultured or lab-grown meat, starts with a simple premise. What if we could produce real animal tissue, actual meat, without the inefficiency of raising an entire animal? After all, people eat muscle, not hooves, organs, bones, or the whole biological machinery animals need to survive. Traditional livestock production creates kilograms of material we never consume, and caring for a live animal requires vast quantities of land, water, feed, and energy over many months or years. Cultivated meat turns this system on its head by growing only the part we actually eat. The process begins with a tiny sample of cells, often taken harmlessly from an animal. These cells are placed in a nutrient-rich medium that provides everything the cells need to grow, multiply, and develop similar to how they would inside an animal's body. With the right scaffolding, temperature, and conditions, they grow into muscle fibers, fat cells, and connective tissues. The result is not an imitation. It isn't plant-based, nor is it a simulation. It is real meat, genuine animal protein produced through a radically more efficient method. This technology offers a way to reduce environmental pressure without requiring the world to abandon familiar foods. For many people, the obstacle to reducing meat consumption isn't ethics or awareness, it's cultural attachment, tradition, flavor, and habit. Cultivated meat addresses these challenges head-on by providing food that behaves, tastes, and cooks like conventional meat because, biologically, it is conventional meat. But beyond nostalgia and culinary comfort lies an even more compelling reason this technology matters: efficiency. Cultivated meat has the theoretical potential to use dramatically less water and land than livestock. Imagine cities producing their own local supply of meat in vertical facilities, just like microbreweries for food, reducing the need for huge global supply chains. Imagine countries with limited arable land gaining food independence for the first time. Imagine removing livestock from fragile ecosystems, allowing biodiverse habitats to recover while still providing the same volume of food. The environmental potential doesn't stop there. Without the need to raise animals, cultivated meat eliminates the methane emissions associated with cattle and reduces the risk of manure pollution, antibiotic resistance, and zoonotic diseases. These aren't distant threats, they are urgent reality. Antibiotic use in farm animals continues to rise globally, accelerating the risk of resistant bacteria that could undermine global health. Meanwhile, zoonotic outbreaks linked to industrial farming have shown how fragile the current system can be. Cultivated meat offers a path to avoid these pitfalls by decoupling meat production from live animals entirely. Of course, cultivated meat faces major challenges before it reaches the scale needed to transform global diets. The biggest barriers today are cost, infrastructure, and public perception. Early prototypes cost thousands of dollars per serving. However, costs have fallen dramatically as the industry has matured, and some companies are approaching price parity for specific products. Large-scale bioreactors, some capable of holding tens of thousands of liters, are being tested, but replicating global meat production requires an enormous expansion of this infrastructure, which will take time. Public perception is another significant factor. Many people are unfamiliar with cellular agriculture and may have concerns about safety, naturalness, or what it means for food to be grown in a facility instead of on a farm. Yet history shows that new food technologies, from pasteurization to fermentation to refrigeration, often face initial skepticism before becoming universal. The more transparent companies are about how cultivated meat is made, the more comfortable the public becomes. And unlike other innovations that shifted quietly into the mainstream, this one is backed by powerful motivations: environmental urgency, animal welfare, and global food security. Governments are also beginning to take the idea seriously. Regulatory approvals in places like Singapore and the United States have opened the door to commercial sales. More nations are developing guidelines to ensure safety while enabling innovation. As infrastructure expands and regulations evolve, cultivated meat could become a central pillar of food policy and sustainability strategy. Imagine future climate agreements including bioreactor-based meat production targets alongside renewable energy and carbon capture. Still, it's essential to acknowledge that cultivated meat is not a silver bullet. Even with rapid innovation, it may not replace all forms of animal agriculture, nor should it be expected to. Some consumers may prefer traditional meat for cultural, economic, or flavor reasons. Some culinary experiences, such as complex cuts or certain textures, remain difficult to reproduce at scale, and the energy needs of bioreactors are significant, meaning cultivated meat will only reach peak sustainability when powered by renewable energy. But its potential to reduce reliance on carbon-intensive livestock systems is undeniable. Critics sometimes argue that shifting food production to controlled facilities distances people from natural processes. But the reality is that industrial livestock farming itself is already far removed from pastoral imagery. Cultivated meat simply replaces one industrial system with a cleaner, more humane alternative. If anything, it may restore balance by reducing the strain on natural ecosystems so they can recover, while freeing agriculture to become more regenerative and diversified. Cultural adaptation will also play a major role. In regions where meat consumption is central to identity, cultivated products may initially enter markets through hybrid approaches, blending plant proteins with cultivated fat to create cost-effective and richly flavored products. In other areas, cultivated seafood may dominate, especially where overfishing threatens marine ecosystems. The flexibility of cultivated technology allows it to mirror local preferences in a way traditional livestock cannot. And perhaps the most compelling part of this story is that cultivated meat is only one part of a much larger transformation in cellular agriculture. Dairy proteins, egg proteins, collagen, and even honey can now be produced by precision fermentation using microorganisms to create identical proteins without animals. These complementary technologies will help supply ingredients for countless foods, reducing pressure on livestock systems from multiple angles at once. Cultivated meat changes the narrative. Instead of asking billions of people around the world to stop eating meat, it invites them to keep enjoying the foods they love without the environmental or ethical compromises. It reframes the debate from sacrifice to possibility, from guilt to innovation. And as we move deeper into the century, where climate pressures tighten and food demands rise, this technology may become not just an option, but a necessity. But cultivated meat and plant-based alternatives, powerful as they are, don't complete the picture. There is a third frontier emerging, one that redefines agriculture itself and pushes humanity toward a food system capable of thriving in a climate-changed world. If the world feels like it's racing toward environmental limits, that's because it is, but the same pressure that exposes the cracks in our current food system is also igniting a wave of innovation unlike anything agriculture has seen before. Alternatives to animal agriculture aren't just about replacing meat. They're about rethinking the entire way food is produced, how we grow it, where we grow it, and how we protect the ecosystems that make life possible. The final frontier in this transformation isn't confined to packaged products or futuristic labs. It's rooted in the soil itself, or sometimes in systems that don't even require soil at all. This is the rise of regenerative agriculture, vertical farming, and sustainable protein sources that challenge the very definition of farming in the 21st century. The story starts with an uncomfortable truth. Modern animal agriculture is heavily dependent on monoculture crops like soy and corn, which are grown primarily to feed livestock. These crops dominate global farmland, often requiring synthetic fertilizers, pesticides, and intensive irrigation. Over time, this approach has degraded soil health, increased greenhouse gas emissions, reduced biodiversity, and expanded the agricultural footprint into vulnerable ecosystems. It's a system built for volume, not resilience. But the world can't afford that trade-off anymore. Ecological resilience isn't a luxury, it's a condition for long-term survival. Regenerative agriculture addresses this reality by working with nature rather than against it. Instead of exhausting soil, regenerative systems aim to restore it, building organic matter, enhancing water retention, and encouraging biodiversity both above and below ground. Practices like cover cropping, reduced tillage, rotational grazing, in specific forms that don't replicate industrial livestock, agroforestry, and multi-crop rotations create vibrant, self-sustaining ecosystems that sequester carbon and improve yields over time. When properly implemented, these methods allow farms to nourish land rather than strip it. Although regenerative agriculture doesn't eliminate animals entirely, it dramatically reduces dependence on the industrial livestock model. Many regenerative farms use animals in small, strategic ways to support soil cycles, not to produce mass quantities of meat. This approach creates a different relationship between animals and agriculture, one that sees livestock as ecological participants rather than commodities. More importantly, regenerative methods create landscapes capable of supporting a wider variety of plant foods that can replace reliance on animal-based diets. But regenerative agriculture, as powerful as it is, cannot alone feed a global population nearing 10 billion. That's where vertical farming, controlled environment agriculture, sea and aquaponic systems come into play. These innovations allow food to be grown in dense urban areas, arid climates, and regions with poor soil, places historically unsuitable for large-scale farming. Vertical farms stack crops in layers using LED lighting, precise nutrient delivery, and highly efficient water recycling to produce vegetables year-round with minimal land. The yields can be extraordinary, up to 100 times more food per square meter compared to traditional field agriculture. What makes these systems especially relevant as alternatives to animal agriculture is their efficiency. Vertical farms don't require pesticides, rely far less on long-distance transportation, and use a fraction of the water of conventional farms. They turn food production into something predictable, scalable, and local. Imagine cities supplying much of their own produce rather than relying on massive logistical chains. Imagine regions vulnerable to drought or desertification, maintaining food supplies regardless of climatic volatility. These solutions don't replace grain fields or orchards, but they ease pressure on land and allow ecosystems to recover while still feeding growing populations. Aquaponics and hydroponics contribute another layer of innovation. By combining fish farming with soil-less vegetable cultivation, aquaponic systems create a circular loop where fish waste nourishes plants, and plants purify water for the fish. water for the fish. Although these systems still involve animal protein, they do so at a fraction of the environmental cost of traditional livestock. More importantly, they provide a blueprint for integrated, resource-efficient agriculture that doesn't rely on land or chemicals. The versatility of these systems allows them to operate in urban basements, rooftops, greenhouses, warehouses, and community centers, expanding food access in places often left behind by traditional agriculture. Another rising star in the shift away from animal agriculture is alternative proteins derived from overlooked sources, particularly insects, algae, fungi, and single-cell organisms. These sources may not yet dominate Western diets, but globally they play crucial roles in nutrition and sustainability. Edible insects, for example, have been consumed for centuries in many cultures. They require extremely small amounts of land and water, produce minimal emissions, and provide high-quality protein, vitamins, and minerals. Mealworms and crickets can be grown vertically in temperature-controlled environments, transforming organic byproducts into protein-rich food or flour. Algae, especially spirulina and chlorella, packs dense nutrition while requiring very little space or fresh water. It can be grown in bioreactors similar to those used for cultivated meat or in open pond systems designed to maximize sunlight exposure. Some companies use algae to produce oils that mimic fish oil without requiring large-scale fishing. Others use microalgae to create sustainable pigments, proteins, or emulsifiers used in meat alternatives, baked goods, and supplements. Algae's versatility makes it a powerful ally in transforming the global food system. Fungi, however, may turn out to be one of the most transformative of all. Mycelium, the root-like structure of mushrooms, can grow incredibly quickly, forming dense networks of protein-rich biomass. When harvested, processed, and shaped, mycelial protein closely mimics the texture of chicken, steak, or seafood. Several companies already produce mycelium-based meat alternatives that cook, shred, and brown like traditional meat, but require only a fraction of the resources. Mycelium grows on agricultural byproducts or low-cost feedstocks and can be harvested in days rather than months. Its speed, quality, and scalability make it one of the most promising alternative protein sources in the world. These innovations, regenerative farming, vertical systems, aquaponics, insects, algae, fungi, aren't just technologies. They form a mosaic of solutions that complement and reinforce one another. Each addresses a different weakness in the traditional animal agriculture system: environmental impact, land use, water use, disease risk, emissions, biodiversity loss, and resilience. But the real power emerges when these solutions intersect. Imagine vertical farms connected to community-run mycelium production hubs, supplying local restaurants and households. Imagine regenerative farms surrounding cities and feeding into vertical supply chains that support plant-based and cultivated meat industries. Imagine food systems that are adaptive, distributed, and resilient systems that can withstand climate shocks and recover quickly. This comprehensive reimagining of agriculture goes beyond simply replacing one type of food with another. It's about redesigning the architecture of food from the ground up. The shift away from animal agriculture isn't just a dietary trend, it's an essential strategy to secure food for the future. It allows societies to reduce emissions, protect ecosystems, and create equitable access to nutrition. It empowers farmers to adopt healthier, more sustainable practices. It fuels scientific innovation that opens entirely new frontiers. Most importantly, it gives humanity a way forward. For the first time in history, we can envision a food system that nourishes both people and the planet, one that doesn't rely on extracting ecological resources faster than nature can replenish them. The question is no longer whether alternatives to animal agriculture will play a role in the future. The question is how quickly we can scale them, integrate them, and embed them into global culture. Because the future of food is already here, and the sooner we embrace it, the stronger, healthier, and more resilient our world will become.